So here we're going to look at an example of this is one of the practice problems from your textbook, of a titration and how we would calculate concentration from a given data set. So one sample you may want to measure is vinegar. Vinegar is an example of an acidic solution. Vinegar is composed mostly of water, but and other things, but has the main acidic part of it. What makes it vinegar is acetic acid. So CH3CO2, so this chemical formula that I've listed right here. And I've listed the H at the beginning to emphasize that this is an acid. And so this is our unknown. We would like to know what is the concentration of vinegar in a sample, or what is the concentration of acetic acid in a vinegar sample that we have. And so we're going to titrate with a strong base. Sodium hydroxide is a common base that is used for this purpose because it's pretty cheap and easy to get. And so if we're going back to our previous picture, our vinegar is down in this flask here, and we're going to titrate with our sodium hydroxide up here. So we have some certain amount that we don't know of acetic acid in the vinegar sample, and we're going to add enough sodium hydroxide to reach the endpoint where the color changes for the indicator. So the specifics for this question are that we have 25 milliliters of vinegar that we start with, and it takes 11.2 milliliters, measured using the burette, of 5.95 molar sodium hydroxide. So we know the concentration of our titrant to reach the endpoint. And if that's true, then what is the concentration of acetic acid in the vinegar sample? So let's go through calculating this, just to give you an example to work with. So what we need to know is, to get the concentration is how many moles of acetic acid do we have? So that is our final goal, is to get moles of acetic acid, which will let us get the concentration of acetic acid. And so what we need to do then is figure out, well, first of all, what's the chemical reaction that's happening in the titration? That's important so that we know stoichiometry. But then also, how many moles of sodium hydroxide did we add? So let's go and write out the chemical equation here. So acetic acid, put the H at the beginning. Just so you know, this is sometimes written with the H at the end, but it's still acetic acid. I will always try and remember to write at the beginning to emphasize that this is an acid. But this is in aqueous solution, will react with sodium hydroxide. And we don't need to worry about necessarily writing the net ionic equation here. We just need to know what's the stoichiometry. So how many moles react with how many moles. So this is an example of where we can practice our acid-base chemistry. We've got a proton donor here, proton acceptor here. We're going to form water. So that's something to always look out for when you're looking at acid-base reactions. When you're looking at a neutralization reaction, acid plus base, you should get water as one of the products. And then we'll get sodium acetate. Okay, and this is balanced already. So we have a 1 here and a 1 here. This reaction occurs in a 1-to-1 stoichiometric ratio. So every mole of acetic acid requires 1 mole of sodium hydroxide to react. So if we can figure out the moles of sodium hydroxide, that will be equal to the moles of acetic acid in the solution. So how do we get the moles of sodium hydroxide? Well, we have a couple of pieces of information here. We know how much sodium hydroxide we added. We know that there's 11.20 milliliters in terms of the volume, and we know that the concentration of the sodium hydroxide is 5.95 molar. And if we remember, if we multiply volume times concentration, that'll give us moles. So our moles of NaOH will be equal to the volume of NaOH, so 11.20 milliliters. Now we're going to need to convert that to liters. So we'll go ahead and do that conversion. This will show up a lot, this conversion. And then we multiply by our concentration. Let me give myself a little bit more space on the side here. So our 5.95 moles per liter, and that's moles of sodium hydroxide. So if we go ahead and multiply those together, we'll get 0.01120. No, that's just me rewriting checking my notes here. Right, 0.0666. There we go. That makes more sense. Moles of sodium hydroxide. So we've taken our volume and concentration that we know for sodium hydroxide to figure out the number of moles of sodium hydroxide. Now the next step is, how do we relate that to moles of acetic acid? Well, it's a 1-to-1 stoichiometric ratio according to the chemical reaction right here. So we can say that 0.0666 moles of sodium hydroxide, we can use the stoichiometry here. For every 1 mole of sodium hydroxide, it reacted with 1 mole of acetic acid. So that means we'll have 0.0666 moles of acetic acid. And we're almost done. Now that we know moles, we know what we had the original volume. Let's go up and look at that again. That should be 25. Yep, it says right up here, 25 milliliter sample. So to find the concentration, which we will sometimes write with square brackets like this, just as a shortcut, instead of writing out concentration of, we just put these square brackets around. We just need the moles of sodium hydroxide. Sorry, not sodium hydroxide. Acetic acid, they just happen to be the same in this case, divided by our volume, which is going to be 25.00 milliliters, but we need to convert this to liters to get the correct concentration units of moles per liter for molarity. So we'll divide that by 1,000 milliliters per 1 liter. If you plug that into your calculator, you should get 2.66 molar concentration of HCH3CO2. So quite concentrated. This is vinegar is fairly concentrated acetic acid. You can smell it whenever you open up a bottle of vinegar. So that's an example of titration. And the main idea here being we're using a chemical reaction, and we use that to figure out how much of a substance is present in an unknown solution. And we have some way of tracking that reaction, finding it when it's done, and that allows us to relate moles of reactants to each other, which gets us to concentration. So we'll get some more practice with this both in class and in your homework, and see you then.